Just out of curiosity for the context of my talk, how many of you are product managers here tonight? So several of you. Okay, good. The way I'll do this, since I do have a lot of slides, and I want to do what's helpful for you. If you have questions anywhere along the way and you just want to raise your hand or shout something out, somebody shout if I miss a question because these lights are kind of bright. And I'm happy to detour and talk a little bit more about anything here. So I'll talk a little bit about myself, why you should think about AI as soon as possible. Probably don't need to convince this group very much since you're already here. This is built off a talk that I give to very business-focused audiences. I'll talk about why this is happening now. Again, I'll sort of fly through that. A lot of you might know it. I'll talk about the PAC Framework. It's not probably approximately correct, which I know some of you know those that framework. 3 key issues, and then I'll wrap up. So as Jeff said, I'm the CEO and co-founder of a company called Tala. We make a sort of IT chatbot, natural language driven, that replaces a service desk like ServiceNow or Jira. Before that, I had a company called Backupify that did backup for cloud computing applications like Google Apps and Salesforce. We grew that company to sort of 10 million in revenue, 90 people. We sold that in 2014. Since then, I've made 24 AI-related angel investments in the last year and a half, both here in New York and Silicon Valley. Some of the more interesting ones that you might have heard of, Floyd Hub, which is Heroku for deep learning. I'm in a really cool chip company called Mythic.ai, which is a low-power voice neural network chip that's super cool. So my thesis was something is going to happen with all this AI stuff. It's hard to predict, but if we can, if I can invest across the entire AI stack, hopefully I'll get lucky and have a good return somewhere. And then I write a popular AI newsletter called, it used to be called Technically Insentient. We actually just renamed it Inside AI since it rolled into that family. So I hope you'll go sign up. I try to take a more applied business approach to this. There's lots of places to go and read about, recurrent neural nets with attention and whatever. And, I'm a former hardware engineer, but I can't do that math and that stuff anymore. So I try to look at what these things mean for the ecosystem and the products and the business models. So why should you care about AI? This is the example I always tell people. You might have seen this on an intelligence test, right? If you have lily pads and they double every day and it takes 30 days to cover the pond, at what point do they cover half the pond? Now, you guys probably all know it's 29 days. Some people say 15 days, right? That's what these sort of accelerating trends are like. And I think a lot of people say, oh, AI, it's so far away. But I actually worry that it's like this, right? And so if your job is to watch the lily pads and let somebody know when the pond's almost covered, that's a difficult job. And here's why it's difficult. Because on day 20, it sort of looks like this. They've been going for a lot of days, and you're like, okay, there's some lily pads, not a big deal. Day 29 and a half, suddenly you go, wow, there's a lot of lily pads on this pond. I should let somebody know. But by the time you get a hold of anybody, it's too late, right? The pond is covered. So I talk to a lot of people that say, well, I don't know about all this AI stuff. We're going to watch and wait and see what happens. And I actually think that's dangerous, because I think what happens is it sneaks up on you, and the companies that are putting their toes in the water right now for their products and their technology are the ones that are going to be at a significant advantage, right? It's not like some of these other technologies, maybe like mobile, where you could catch up, right, if you were behind. So I'll talk about some of the reasons for that. So why is AI accelerating? Number one, computing milestones. Most of you probably are familiar with these things. This is an interesting one I found from Bloomberg, and this isn't even factor in 2016 and 2017, but this was AI projects at Google. So you can see the growth at Google of projects that use AI-related things. And this is my favorite. If you know anything about the history of machine vision, you might know that sometime in the 1950s, Marvin Minsky gave it to a grad student as a summer project, hey, solve machine vision basic image recognition. So I don't know, that was probably 1956 or 58 or somewhere then. So over the next 60 years, we basically go from 0% to, call it, high 60s in terms of an accuracy rate. That's not very fast progress, right? And if you've ever worked with, I used to work in, build, hardware boards and circuits, and they would build these machine vision things to recognize if the chips were put down out of place or anything else. And they were incredibly expensive 7-figure machines, and the machine vision technology was really hard and just tailored towards that application. And that wasn't that long ago. That was the early 2000s. And so suddenly with convolutional neural nets and deep learning, after 60 years of making slow and steady progress, we basically went from less than 70% accuracy to human level accuracy in just a couple of years. So I think this is super interesting, and I think this is one of the reasons that AI really has staying power this time around. Part of the bet that we made with Tala was that natural language processing will go through something like this over the next 5 or 6 years, and we want to be there when that happens. So this is a great graph from a post from the Wait But Why blog, which if you haven't read it, I hope you will. And he says in there, the post is about AI. Here's the link. And he basically says, look, this is about to happen to your business. And this is why you have to pay attention, right? Because we're sitting there in that knee of that curve, and as this one shows, we humans tend to think about sort of linear growth, and we extrapolate. And if you're about to go through one of those inflection points, we're not thinking about it very well. So if you are a product manager or a business person, or touch on AI, or AI would be useful to your business, you need to be thinking about this. And this is why you don't want to be caught suddenly saying like, man, I saw this coming, and now we just we can't do anything with it. We're too far behind. So reason number 2, AI is a flywheel. Now, I don't know if this will always be the case. I think that's a really good question. But right now it is, right? Right now you've probably heard data is the new oil. And you see patterns like this, right? The companies with the most users generate the more data, which they feed back into the algorithms. They get better models, which leads to a better product, which gets you more users. There's a lot of work being done on small data machine learning, and there's a lot of things that may change this, but I think at least for the next 4, 5, 6 years, this flywheel effect is definitely going to hold true. And at least until AI sort of surpasses us in what we learn, I think there's definitely a flywheel in your organization, right? Getting to learn about AI, understanding how to deploy it, understanding some of the challenges that we're going to talk about tonight is really, really important. It's one of the things I think when I do a lot of investing, it's been interesting to watch as an angel investor how VCs approach AI, because you sort of have 3 camps right now, right? You have some VCs saying like, we don't understand any of this, we're just going to sit out. The risk there, I mean, you get smarter and you get a chance to make smarter bets later, but you miss out on probably the first wave of AI winners. Then there's some that are like, oh, this is sort of like vertical SaaS, which is really not in terms of the metrics or in how you build the company. So those people are probably going to make a lot of mistakes. And there's the people that say, we don't really understand this, but we think we need to play in this space, and because we need to learn. And a lot of people think, like we're here at Google, I mean, clearly, one of the companies driving a lot of this innovation. A lot of people think that because of this flywheel effect, there's no way for startups to compete. But I actually think they underestimate at this point still even the human pieces of this, right? Just the things that you learn, the battle scars from tuning hyperparameters or whatever you do related to this stuff can matter a lot. I don't know how many of you have ever tried to put some neural network in production that you read about in a paper, but it's hard to get that shit to work, right? Like we've done it a couple times at Tala. There's a really good video you can watch actually if you Google Tala neural Turing machine. One of our data scientists basically banged his head against the wall trying to put a neural Turing machine in production based on the paper, and it was a little more finicky than he hoped. But anyway, I'm getting derailed now. So how can AI help you? So there's a couple ways to think about this in your product or in your business, right? Number one, getting the right information to the right person at the right time is the kind of use case that is good for AI. Extracting valuable insight from data automatically so you can replace a junior level analyst of some kind is a really good example. Assist with decision support, right? Pulling information together and helping with the analysis and making recommendations. And then amplifying your productivity through task automation. There are a lot of tasks that you think, I wish a robot could do this task. And it hasn't happened in the past because trying to write all the rules for it, the system was just too brittle, and machine learning can solve this now, right? So this is a good area to look. And so when I talk to business groups, I talk about this PAC framework, right? And it stands for Predict, Automate, and Classify, which I think if you're getting started in machine learning, either in your own product that you're building or just in your company in general, I think those are the 3 use cases that you want to look at. There's a lot of things you can do with machine learning, but predicting things, automating things, and classifying things are where you're going to see the best bang for your buck early on. And then there's 3 key areas to consider: your customers, your product, and your operations. So I probably should put this slide first. So here's a functional use case, right? Let's say you wanted to apply AI to recruiting. So maybe you want to predict. What would you predict? Who will be successful in the job? Who within our organization is ready to jump to a new job, either because they're becoming disinterested and too good at the job they have, or it's the next level of growth for their career? What would you automate? Setting up interviews, collecting feedback about those interviews. I'm sure many of you have had the experience where somebody taps you on the shoulder and says, hey, you're ready to go interview Sue, and you're like, oh, great, what's she here for? What's she interviewing? Do you have a resume? I forgot. And then sometimes you want to make a candidate an offer really, really quickly, and you chase people down, and like somebody who interviewed her now is gone to the dentist, and somebody else already left for the day, and somebody else just went on vacation. And like even tracking those people down, right, if you could just automate that process is pretty simple. Or classify, bucket resumes as they come in based on certain types of data. Now, with recruiting in particular, you have to be a little bit aware of the sort of garbage in, garbage out problem, right? I think if you're going to judge candidates based on resumes, you're not going to get candidates who are similar. You might get candidates who write similar resumes, which can be a big distinction, right? So always keep that kind of thing in mind. And then this is how you might think about the full framework, right? So I do this because when I talk about this PAC framework, a lot of people say, okay, well, give me some examples. And so this is what I would do if I was a senior executive at a big company and I was concerned about AI. I would put my customers, my product, and my operations, and I would put automate, classify, and predict. Or you could make this just for your product, for example, if you're a product manager. And then I would start to look at some of these specific things and say, okay, how could I automate pieces of my interactions with customers? How could I automate things on my product, right? How could I predict pieces of my operation or things within my product? And then I think you want to look at a couple of things, right? Where are you going to get the most bang for your buck? Which ones of these 9 blocks are going to be the most interesting for you to either really have an impact on your business, or maybe they're going to be the easiest to implement, or something like that. And so here's the questions I would ask, right? What's the ROI? If you're more technical, one of the things that I always tell the engineers that work for me is, something breaks in the system and a bunch of customers complain and they come and they say, well, I could have told you that was going to happen. I saw this coming. Redis was about to fall over. And I say, well, why didn't you raise the red flag? And they say, I did. Nobody listened, or people didn't care. And I said, can you put it in terms of customer pain to me? Because if you send me an email and you're like, Rob, I think this is going to happen with 80% certainty. And by the way, here's what it would mean from the customer's perspective, because I don't know all the technical jargon anymore, right? I'm not in the code. So anytime that you want to justify anything to your boss, and you can use an ROI analysis, even if it's just loose and off the cuff, that's going to be helpful. Do you have the data to do it? So if you're starting an AI company, the place that I would encourage you to look is how can you build something that gets access to data that nobody else has, and then use that data in a really cool and creative way. Right? Because that's how you're going to win against some of the big guys, where the existing workflows and models that we have, they don't generate data about everything, right? There's a whole bunch of things that you could do that there's no data set that exists to do it. Does the data set drift? This is one of the biggest things that people miss, right? So if you trained a machine learning classifier on human height in 1912, predicting that at birth, it would not be very accurate now, because the data set of height has drifted based on improvements in medicine and nutrition and everything else. And so when you're looking at building these machine learning models, you have to think about the underlying drift in your data set. And if it drifts very quickly, you definitely have to figure out a way to take that into account. And then what tools do we use? Which, there's been an explosion in tools. My hope is that over the next 4 or 5 years, they'll start to consolidate a little bit as the winners in the market rise up. So 3 very specific issues for you if you're a product manager related to this. Number 1, data science is not engineering, right? So again, if I want to go to my lead engineer and he's saying, based on our user growth, the database is going to have this problem at this time, and I say, here are options to fix it. We can move to a bigger instance, we can shard the database, we can do blah, 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 blah. He's going to have at least a good heuristic for how long all of those things are going to take, right? Now, if you're a product manager and you go to your data science team and you say, this classifier for this thing is about 80% accurate, and we're not quite getting traction. I need you to make it at least 92% accurate. They're going to say, Great, how long do you want us to work on this? Like, they don't know how long it takes to make it 92% accurate. They can try some things, they can try, and maybe the first thing they try gets them there. Maybe 6 months later, it's 82% accurate, and they haven't made much progress. But most things in data science at this point, if you're using a lot of these newer neural models, is that they're harder to predict and they're harder to understand, and they're not cleanly packaged and abstracted away the way that a lot of engineering tasks are at this point. It's also still very researchy. So a lot of times, it's particularly hard if you're working on 2-week, 3-week, 4-week sprints with your engineering team and you want to put some data science, some AI into your product. It's actually very, very hard to sort of map those together because data science still has a lot of stuff where it's like, hey, go off and try this and see if you can make this happen or see what you can do with this data or run this through some visualization analysis and see if there's anything there. So it's one of the way that data science and engineering teams work together, like there's a lot of people doing a lot of really innovative operational work here. But I think it's one of the biggest things as a product manager that you have to understand is that these are actually very, very different fields. The way people work are different, the way they approach their work, the tools they have, and so you have to be careful. And this is one thing that I think is interesting. So a friend of mine is a guy named David Murgatroyd. He's a VP of engineering at Spotify. He was at Basis Technologies, an NLP company before that, and so he's probably one of the best people in Boston to understand the intersection of sort of data science and engineering because he's done it for a long time. And he actually recently gave this talk. I have the link here on a later slide. So if you go download these or if Jeff posts them somewhere, you'll be able to go watch the talk. But he talks about how you do Agile deep learning. And I think the key thing to point out here to address this problem is this sort of inner loop between explore and experiment and prioritize. And so as you're making your plan, you do have to have this subloop of let's see if this plan's reasonable. Let's run these experiments to see, oh, we did some small tweaks in our 80% classifier, quickly got to 84%. We have that uncovered some other ideas that we think will quickly improve it, right? That gives you hope that 92% is reasonable. And if you think those little numbers don't matter in data science, they do, right? If you look at something like Siri, part of the, I forget the specific numbers in the article I read, but part of the theory for why Siri suddenly became more widely adopted was even at like 92, 93% accuracy, it's just not good enough. You learn not to use it because it's not good enough. And then I think as you get to like mid to high 90s, suddenly you're using it for everything, right? So these things matter in AI products. Issue number 2, testing. How do you test something whose output changes as people use it? There's a lot of people talking about autonomous vehicles, but there's a lot of people who think level 4 and level 5 autonomy is much, much further off than we think. Like it's not 5, 6, 8 years away. It's 20, 30, 40 years away. We don't realize as humans that we design this world to work for us, right? Like we built roads and cars and everything to work for the way we're built and the way we naturally think. And so there's things that we don't even think about doing that a machine that has an entirely open-ended set of behaviors might think about. You have to find some way to teach it that or get it programmed in. And so, to give you a bot example of this, we run into this issue with Tala, right? Which is when we change a language model, how do I know that for the infinite number of things you could say to Tala, Tala still says the right thing back, or even what it should say, right? Regression testing is hard, and not only that, but you're going to deploy these products to customers, and they're going to change, and they're going to do things that you didn't anticipate, maybe, and these are harder things to engineer for and harder things to test for. And so, part of my advice here would be think about some real-world, real-time feedback loops, like constant feedback from the, from the users for the things that you're building, so that they can tell you as things are getting out of whack. This is another interesting issue, also from David Murgatroyd's talk that I saw on bugs versus errors. So when you put a machine learning model into production and it doesn't work as anticipated, you have to figure out if you're dealing with an error or a bug, right? Does the model work but you implemented it incorrectly in code, or does the model just, you implemented it correctly but it doesn't do what you thought it did, right? So those are two different issues, and the way you're going to track them down is going to be very, very different. So you want to be able to distinguish between these things. And then the third issue is data is messy. So I haven't written any production code in, what year is it, 2017, so probably 13 years now. And so when I decided to start Tala, I said, you know what, I should understand some of this stuff better. Like the last time that I wrote a lot of code, it was C and C++. I'd never done anything like Python. And so I hired a data science coach just for a couple of months to walk me through these projects. And what I learned was like 90% of data science in an NLP project was like getting the data, cleaning the data, putting the data in the right format. And then like 10% was the fun stuff that we actually did with NLTK. And so this is something that I think people don't think about enough when you're going to do product management in AI, which is, oh, okay, it seems easy, right? We have the data and we want to do this thing, like great, that should be really easy, right? You're gonna like spin up TensorFlow and you're gonna shove the data in there and it's gonna be magic. And it's like, man, you might spend weeks or months or longer just trying to get the data consolidated in the right format and all that kind of stuff. So if you're building AI products, just remember that data's messy and factor that into your timelines and the way that you're doing the stuff that you're doing. So very scary in some ways, right? We're gonna release products that we can't test, that take too long to build, and we don't know how long that is. But it's also very exciting, right? If you're in this field, there's a lot of chances to be the person who solves some of these workflow issues and come up with some of these challenges, right? I mean, everything that we have today, every methodology we use at work didn't exist at some point. So maybe you can be the guy or the gal that invents some of these things for AI, which is a really cool opportunity. Tools to consider. If you Google this is the Machine Intelligence Landscape version 3.0 from Siobhan Zillis at Bloomberg Beta. She's probably the smartest AI VC out there that I've met. So, and there's way, way, way more stuff than this even out there, but it's a good place to start when you're looking for tools for specific things. A little bit about Tala. Like I said, we work like a service desk. So the thing that we do is we automate a lot of tier 1 support for big companies, but we're entirely internal focused. You heard me talk about the problems in testing this stuff, right? So I think a lot of people that are in the sort of customer support chatbot space, I think it's a tough space to be in. I wouldn't want to be in it right now given the state of NLP, so we're focused entirely on internal service teams, sort of automating tickets and wikis and stuff like that. So if you're in AI, I'd love for you to play around with it and like give us some feedback. It's pretty cool. And then here's some resources that I linked to. So David Murgatroyd's talk is here on SlideShare. There's a great post on VentureBeat written by a guy who did product management for us for a while now. He's running biz dev, named Will Murphy. 12 tips for designing and managing an AI-driven product. And there's a great post on Hacker Noon that I linked to a couple of newsletters ago on machine learning and product managers. So there's starting to be some content out there. There's not a lot. There aren't a lot of good frameworks for thinking about it, but people are putting in the time and starting to ask the questions. And so all this will become